Are we alone? And just how big is space? Planetary Society Chief Scientist Bruce Betts joins us with the answers on this month's Planetary Radio Book Club edition. Hello again, Planetary Radio listeners and lovers of books about our solar system and beyond. I'm Mat Kaplan, Senior Communications Advisor for the Planetary Society, the former host of Planetary Radio. Bruce Betts has completed his series of space books for young people. The Size of Space collects many of Bruce's successful and very entertaining attempts to reduce the vastness of the cosmos to human scale. The other book, Are We Alone?, borrows that greatest of questions that drives so much of science and is at the core of the Planetary Society's mission. Bruce is still the only human being who has been heard on every episode of the weekly Planetary Radio series, with me for the first 20 years and now with host Sarah Al-Ahmed. But he has done so very much more for us across his many years at the Society, including his brilliant management of the LightSail Solar Sail Project. He's a planetary scientist whose PhD studies at Caltech were overseen by our co-founder, Dr. Bruce Murray. Bruce Betts spent 3 years at NASA HQ and has crossed the globe in his work for us and others, including the Planetary Science Institute, where he is an alumnus senior scientist. You're about to hear much more about my good friend in this recording of the live-streamed conversation we had in the Society's member community as 2026 got underway. We are here to talk about Bruce's latest books. You see a shelf full of them behind him there. Here are the two latest and, as I understand it, last books in the series. Am I correct?
Yes, you are correct. It is a 15-book series, if you count all of them going back to the Eclipse book, and one for each planet, and a few for other objects besides planets in our solar system. And then we finish off with a couple different topics. Measuring the size of space. Basically, it's, for those who may be aware, it's basically random space fact with a little introduction to talk about scale models and things like that. And I pulled out some of the coolest random space facts, had the art department do some things, found some images, and made a groovy book. And this was part of a Planetary Society partnership with Learner Books, who is particularly active in school libraries. So feel free to tell your school library to check these out, or you can order them for yourselves at Amazon, or if they're seem to have inventory weirdness sometimes. So first, go to the Learner Books and check out all the books there.
We'll talk about the books, but I also want to talk to Bruce about his job and how he ended up in this work, and about the Planetary Society and our mission and how he contributes to it, and how he has done that for many, 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 many years. I think roughly almost as long as I've been around TPS.
Yep.
But beginning with the books, which is a great place to start. How did this come about? How many of them are there? Why did the Society decide that we should make you the author of this whole series that lists the Planetary Society right up there at the top of the book?
I don't really know the answer, other than they made a mistake. I can mention that I had, as you can see on the shelves, 6 books before I started writing these separately with different publishers. And so there was a basis of, I've been writing children's space books at all levels, from my first book of planets up to teens and adults. But yeah, to actually be willing to get a book that says it was for children. But I've had many adults enjoy them, particularly all the levels. Anyway, our partner group and leadership team, including Rich Chute and also Jennifer Vaughn and the gang, made contact with Learner and worked out this deal where basically we would contribute a series with using our solar system planetary knowledge, and they would publish and distribute it. So you will see that most of these are nicely branded with Planetary Society, and it's a way we're trying to work more with educating children, kids, getting them excited about space, getting them involved and showing them all the beginning of all the neat stuff with space. So that's kind of where its genesis, and then we worked out, been working over multiple years, kind of working on coming up with what's included and how it's structured and the whole 9 yards.
I heard now and then from you and others how much work this was, because it was this long stream of books. And, anybody who thinks that putting together a book like this, which is, it's fairly thin, it's fairly typical for what you do for kids, that this would be an easy task, you put a lot of work into these.
I did. Hopefully it shows in the product and wasn't just a foolish waste of time. No, every time one of these comes out, I feel a great sense of accomplishment. And then I pick it up and I realize it's, fairly thin. And I am not really sure how I spent that much time. But trying to get the language appropriate for the age group, trying to figure out what you have to do, a lot of squeezing things down, figuring out what you throw out. So, I love space. I've been studying it my whole life. So there's all sorts of things I want to put in there, but you need to fit fairly tight constraints in the process. And then I am obsessed with images. And so finding images that are real images when possible and art when not, and finding the best representative ones where, again, you only have room for a few, and trying to have a caption that, although short, gives you an idea what you're looking at, and whether, for example, you're looking at something your eyes could see or something in the infrared otherwise. So anyway, I found a way to spend a lot of time on them, so hopefully people enjoy them. I mean, some people do.
I know that
my relatives.
My grandson is going to. I haven't even shown them to him yet. No, especially the size of space. I think he's going to love, because he already knows everything about astrobiology. But this is
how old is he now?
He's 9.5. Yeah,
okay,
good enough. 2 PhDs so far, but he's a slow learner.
Wow.
He
published astrobiology papers?
Yeah, all the time. You haven't seen them? You've been too busy writing books. They're perfect. What is the age? What age are they targeting?
Targeting second to fourth grade. Talking Americans, kind of 4 to 7, 8. So it's a kind of in that range, but hopefully it target that. You're interested. Even younger kids like it at some level, and then older kids can digest it.
It's full of your wonderful random space fact analogies and demonstrations of scale. Let me bring up some of your examples, some of your random space facts, beginning with mouse, Earth, and elephant, sun.
Yeah, I like that one. The way it's expressed here is that if the Earth were the size of a mouse, then the sun would be the size of an elephant. And I took out all the part about what kind of elephant and what gender, but it's really an expression of mass, to be perfectly honest, but it roughly conveys to the size of the animals. And indeed, and there's a lovely elephant picture that we found in there, and a mouse, and that's about the difference, because we're really tiny and the sun's really big, and that's what I tried to convey, Matt. Did you know that? Mouse, elephant, small, big.
I didn't until I saw that example, of course.
Oh, good.
I'll tell you one that honestly did kind of surprise me, even though I have known many, many years that Mount Olympus on Mars, is that much huger than Mount Everest. It was actually seeing them in the book laid out against each other, Everest in front of this behemoth. That is so impressive. And I'd be showing more of these pictures, but people are going to be listening to this on Planetary Radio, so I decided not to. But get the book, folks, and you'll see it. It's a monster.
It is enormous, both in height. It dwarfs Mount Everest, and in breadth, because it's a very broad shield volcano, more like a Mauna Kea or Mauna Loa with the very shallow angles. As I've heard it phrased that it's the size of Arizona. Also, I went international, and it's the size of Poland.
Poland is the size of Arizona?
That would be by the transitive property of geographical silliness, yes.
Yes, A equals B, B equals C, therefore A equals C. I remember the transitive. It's about as far as I got in math. If the sun was at New York City and not huge and burning it up, take it from there.
And you put Neptune in L.A., so sun, New York, Neptune, L.A., then the Earth would be orbiting roughly at the distance of Philadelphia. So we show graphically the point is the Earth is much closer to the sun than Neptune is. Neptune about 30 times farther away from the sun than the Earth is. And it's a way to really see it, at least for those familiar with the United States contiguous geography, that really did it. For me, I was pleased when I came up with a city comparison that was pretty accurate. Did you recognize my son in any of these pictures?
No, not your S-U-N, but your S-O-N. I know you dedicated the book to your sons, both of whom I know, fine fellows, and to the members of the Planetary Society.
Yes, I have a picture of Kevin, the younger, Daniel, the older. They're both fine men now in their 20s, but at this time, Kevin was somewhere in the preteen, and there he is, kicking the Earth. Getting ready to kick the Earth. Where the random space fact with some manipulation of the photo is if Earth were the size of a soccer ball, professional soccer ball, then Jupiter would be about pretty darn close to the height of a soccer goal.
So this reminds me of the brilliant stuff that you did for a long time with our brilliant video guy, Merc Boyan, the Random Space Fact series, which are still on our website. If you check them out under the video, they're so entertaining. And my grandson, I already know, loves those. Even when he was like 4 years old, he just loved lining those up on our website and got it.
Yeah, if you're not familiar with, we did working with Merc Boyan, our video guy, a few years ago. We did a number of Random Space Fact videos where they're a minute or two long and have real science fact, gee whiz, and then usually I get hurt and it's funny, at least for kids.
Yeah, either you get hurt or you get embarrassed somehow, or you break your car somehow. There's one, I think, where you...
Oh, my poor car. Although my car suffered a fate very similar to, well, not really, kind of similar to, it deorbited. It came in through the atmosphere representing a car-sized asteroid entering the atmosphere and burned up. In this case, it just burned up in the Eden fires that were about 1 year ago, just melted most of it. And that's not important right now.
Word of explanation, Bruce lived in the center of the Altadena fire, more or less. And that neighborhood is pretty much gone. But you're doing okay, right?
We're doing good. We got ourselves and the dogs out and plenty of time, and thought we were just evacuating to be cautious. And everything, no, wasn't caution.
Well,
everything, us and everything around it was wiped out. I'm sorry, it was caution. I get a little distracted when I start talking about it.
Understand.
But that's not important right now either. That's my theme for this, is what's not important right now. That was very important in my life, but Random Space Fact videos, there's a playlist. I don't remember if that's linked easily from there or not, but on YouTube you can find all of them. But there's about 50, and we have fun. And a couple of those made it into the book as well. Ones that are similar. If our solar system out to Neptune were the size of a quarter, then the galaxy, Milky Way galaxy, would be the size of North America.
Yeah, that's another one of the ones that I made note of. But here are two, at least, that got my LOL. One of them I was completely unfamiliar with.
Yeah, I was surprised that everyone went along with me, including the ones at the back. But
one in particular, I bet, was the one that was in question.
Yeah, go ahead.
Yeah, here's the first one. fingernail growth.
Oh, yeah.
With illustrations. Yeah.
That was the learner got the illustration made and with my description. And so, yes, if the moon gets farther from the Earth in its orbit, in 1 year, it's about the same distance as your fingernails grow in 1 year. There's a lot of variability in fingernail growth, but at least kind of an average fingernail growth. That's how it turns out. And one of the amazing things, I didn't say, there's actually a third coincidence, which is that's also the approximate rate that the mid-ocean ridges are expanding outwards from the rift.
Tectonics.
And what did I say? Do you have it? It's a few centimeters.
I'd have to hold it up. Let me see here. I'll see if I can.
Yeah, it's okay. I'm supposed to remember the number, but I just have those cool analogies, and everyone knows how fast their fingernails grow.
I can't see the camera to be able to do this properly, but there you go. There are the fingernails.
Oh, and the cheeseburger looks good enough to eat.
Yeah, it does actually.
This also has Rover the dog and Luna the robotic cat and dog that participate in our kids membership program, Planetary Academy, and the content from that is tied to the content in these books at some level. And in this particular one, the publisher wanted to use those creations of our designer, and they're super funny and cool. Fun and cool. Fun and cool.
So here's the other one, and you probably can guess which one it was that I cracked up.
Well, sure.
However, it's right at the end of the book. A couple of facts about Uranus. You would have to unroll more than 47 billion rolls of toilet paper to reach Uranus, from Earth.
Yes, you would.
And then this cute little illustration that says, if the sun were the top of your head and Pluto were the bottom of your feet, then Uranus would be right where you'd expect it to be.
Really? Yes, that is the most popular random space fact I've ever come up with.
How did you come up with this?
Sometimes for every successful calculation, there are a bunch that aren't successful. So I kind of hunt around, and that one I was like, oh, well, it'd be neat to do like a human body type thing. And let's say, well, why don't we and then I just calculated, and it's like, wait a second. And, I was standing up with measuring tapes and going, well, that's funny. That's very funny.
I'd like to have seen that little proof.
Great moments in random space fact history.
It does seem kind of cosmic that it works out so well, actually, at least to me.
You do have to use Pluto instead of Neptune. Although, bodies vary. It's kind of like fingernail growth. Yeah.
Before we go on to the next book here in the book club, let me look over what we've got here. I said that Timothy had a question quite a while ago, and I hadn't been scrolling down. I see a whole bunch of you have now. Timothy said, how many Earth-crossing asteroids could there be? And he says, explain the blind spot a little more. So there's an estimate, isn't there, for the number of near-Earth asteroids, which is another thing that Bruce is quite expert on and represents us at such things as the Planetary Defense Conference when it happens every other year.
It's true. I was going to say I don't use random space facts, but frankly I have, because we did talk about how to do public education and outreach about the asteroid threat. And so, to be very specific, I don't have a number in my head for current Earth-crossing asteroids, by which I assume you mean crossing its orbit. But what the so-called planetary defense community usually uses are a couple of defined things. One of them is near-Earth asteroids, or NEAs, or near-Earth objects, NEOs, which includes a small handful of comets. And the NEOs come within 1.3 AU of the sun, AU being astronomical unit, the distance from the average distance Earth to the sun. So they get close enough to the Earth that even if they aren't crossing our orbit now, the concept is they're that close, a perturbation from Jupiter, gravity, or something else within, I believe they the modelers are like 1,000-year time frame, it's not unreasonable that they might be thrown into an Earth-crossing orbit. So that's the kind of the ones we want to pay attention to and find. We found approaching around 40,000 of those currently, and the estimate gets really big if you talk about NEOs that are big enough to do damage affecting people. So kind of the Chelyabinsk and above, so the 20-meter diameter asteroid type thing that's going to come down, doesn't hit the surface, it's doing it. There's an air blast that can cause damage, and the estimate is there are about 1 million of those NEOs, of which we've found 40,000, and we're doing great compared to where we were, which was almost none at the turn of the century. And so those numbers are going up and up, and you find the most dangerous, the biggest ones, the easiest, because they're the biggest and reflect more light, easier to see. So that's the good news. And we found we're probably over 95% estimate of the 1 kilometer and above, the real global disaster. But the numbers get worse as you get smaller objects. So we're still the most important thing in planetary defense is find them. But until you find them, track them, and get some basic characterization, and most importantly, whether their orbit is targeting Earth at the time, you can't do the next nifty parts like slamming something into them to change their orbit. Anyway, that's my little pitch for let's do it. And we're doing better and better with the ground-based work, and we've got NEO Surveyor, which we keep pushing to make sure it doesn't drop out of the budget at some point, and that will be a space-based telescope that the community has been really wanting since the Planetary Defense Conference started 25 years ago. This has been the big goal because the blind spot, and I'm not exactly sure what you're referring to, but not surprisingly, it's very hard to find objects like on Earth coming out of the sun. And so some of these go inwards of the Earth, and then the sun is in the way. It's more complicated if you're on the surface of the Earth. And so NEO Surveyor, even though it won't be that far from Earth, it will pick up a much broader swath of sky that it can look at any given time, being towards the sun. It's designed, I believe they're still on the putting it Earth-Sun Lagrange point 1, which is about 1.5 million kilometers towards the sun. And that will enable it to see a lot more of the sky without that pesky sun interfering. It's also infrared-based, which turns out is more. You can do a lot better often with that than with visible. Depends. You want both, really. So that's the blind spot I think of, which is anything where it's inwards. It really is an Earth crosser, and it's inwards towards the sun. It's extremely hard to pick up. So Chelyabinsk came out of the sun in 2013 and was not picked up, not seen. Of course, they orbit farther out, so you're going to pick them up or have the option to pick them up later, as long as they're not on their impact dive at the time.
That was my guess as well about what he was probably referring to. With the
sure was, man.
Spot. So we got a useful note here, once again from Rich Chute, who's really proving himself helpful tonight. He says RSF's Random Space Facts are also available in schools on the EPIC platform, where they get hundreds of thousands of views every year. I did not know that. Apparently you did.
That is so cool. I did, and Rich has been great about passing that information along, and I have not publicized it enough to you, Matt. No, it's really cool and very gratifying, and there even, at least there were, I haven't checked recently, hospitals that use them, a couple of them at least, as kind of running on a channel on their internal system, especially for kids. But the school thing is very gratifying on the EPIC service, that there are that many views and people checking them out. So it makes us feel good.
I got to go back into it and see if my grandson is still as excited and entertained by them as he used to be. I bet.
Well, if he's not, don't tell me.
Okay. Let's see. Dave said, wait, the Earth's orbit is growing in size? And then was answered by Diana, the moon is moving away from the Earth, which is what you were talking about with the fingernail thing, right?
Right. Tidal effect. It's a tie to the Earth. The Earth's rotation, in other words, the length of our day, is getting slower. That's what happens to the Earth with this tidal effect, and the moon is getting farther away. And they're both very small from a human standpoint, but significant over, geologic time, to say the least.
And Timothy just posted, don't worry, the moon isn't escaping anytime soon. It's actually moving away very slowly, which is what you were just talking about.
Right. No, we're good. We're good for a long time. It's not pulling the moonfall thing and almost crashing into the Earth either. I don't think. I mean, no.
I'm not worried.
We're good.
Do you remember the name? It was a short-lived Steven Spielberg TV series, which I think most of them have been, sadly, where they go in a time machine back into the past, and they did a cool thing. When they look up at the night sky, the moon is huge because the moon is substantially closer to Earth. But Terra Nova. Thank you, William.
Wow, that was quick feedback. No, I do not remember it, and I didn't know they did that. And could have just been because they had thick glasses on and metal thicker.
I don't think so. But they had a time machine, which is much better than glasses. And we will talk about Are We Alone?, the other of Bruce Bett's great new books for young space fans, when Planetary Radio's Book Club edition continues in moments.
Hi, y'all. LeVar Burton here. Through my roles on Star Trek and Reading Rainbow, I have seen generations of curious minds inspired by the strange new worlds explored in books and on television. I know how important it is to encourage that curiosity in a young explorer's life. That's why I'm excited to share with you a new program from my friends at the Planetary Society. It's called the Planetary Academy, and anyone can join. Designed for ages 5 through 9 by Bill Nye and the curriculum experts at the Planetary Society, the Planetary Academy is a special membership subscription for kids and families who love space. Members get quarterly mailed packages that take them on learning adventures through the many worlds of our solar system and beyond. Each package includes images and factoids, hands-on activities, experiments and games, and special surprises. A lifelong passion for space, science, and discovery starts when we're young. Give the gift of the cosmos to the explorer in your life.
Let's talk about this one. Are We Alone? Searching for Life Beyond Earth with the Planetary Society. Bruce Bett.
That was a great quote. I'm sorry. They had a time machine. That's better than glasses.
Yeah. Again, fun book and a great introduction to the search for life elsewhere, to astrobiology. You cover a lot here, like what's happening in our solar system and looking at extrasolar worlds, and also eventually SETI, which is all stuff that the Planetary Society has been deeply involved with, right?
Yes, we have. We've been... We started funding SETI, and within the first year or two, the organization started in 1980, and we're funding efforts. We worked with Steven Spielberg, or at least he made contributions to our program when he was making alien movies, and he helped throw the pretend switch to fire up one of the searches that was run by Harvard University, and Paul Horowitz there ran several, going from radio astronomy even to optical, looking for laser signals. The answer to skip ahead is no, we didn't find anything. But the other part of the answer that I feel like people haven't been given enough information to appreciate, it's a really big haystack that we're looking through the needle. So I don't find that surprising at all, even if there's a lot of life out there. The distances involved, the powers involved, the fact that you have to be looking in the right place at the right time, see it multiple times to believe it, be looking at the right wavelength, be able to interpret the signal, able to sort it out from other forms of human radio interference, which, by the way, one of our recent STEP grant winners at UCLA is been using, developed a program that we help sponsor, which is using citizen scientists to go through and help them categorize the Earth interference noise in the radio signal, because one of the hardest things about SETI is sorting out all those pesky human signals and figuring out what might be an actual intelligent alien signal. But as you say, in the book, where I start more basic, which is life on Earth and the three things life requires. Well, four things if you count Matt's sonorous voice. But
Thank you.
Thank you very much. Energy source, liquid water, which guides a lot of our searches, and then the right kind of atoms, molecules, building blocks to fiddle with. In a nutshell, is at least what Earth life requires. And so then we kind of start there in the book and move into places in our solar system where we're most intrigued by the possibility of past or present life, from Mars and the obvious lots of liquid water there in the past, to Europa with its liquid water ocean, crazy and Enceladus was spewing out geysers. So, and then we go out and at least touch in the subjects of looking elsewhere and looking at exoplanets and the concept of the Goldilocks zone of where it's just right temperature to keep your liquid water oceans on the surface, or the expanded Goldilocks where you have things like subsurface oceans, blah, 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 blah. It was fun. That one was a challenge to write, I gotta say, because taking the field of astrobiology and making it digestible, hopefully I succeeded, but obviously it's like anything else. You do a book on Mars, you're only scratching the surface. You do a book on astrobiology, you're only scratching the surface, but you're trying to do it in a way that gets kids excited and gets them the basic gist, so that hopefully later on, or even after they read that, they go look for more information and dig deeper.
Yeah, it's all about whetting their appetites. And by the way, you mentioned STEP grants, science and technology empowered by the public, right? I got
nailed it.
Okay, nailed it this time. And also a program that Bruce is in charge of, where we fund this great research by people all over the place.
So we've got 4 great projects in the few-year history so far, and so we're looking for probably a couple more.
We'll
to come. See, and it's open to pretty much anyone, but obviously you have to convince us that you're going to do a project and have the skill and the equipment and whatever, and it's a realistic budget and things like that. The usual for tech proposals.
So far, so good. Some really, really good stuff. In addition to our Shoemaker Neo grant program for finding those rocks that are headed our way, which we won't go into today because we don't really have time, but check those out on the website as well. I'm going to give another gratuitous mention to Steven Spielberg. If you're watching, Steven, call Rich.
We got a sponsorship that I missed. Rich, do we get money every time you mention Steven Spielberg?
There is the picture of a much younger Steven Spielberg throwing that fake switch that Bruce mentioned. If you're ever lucky enough to get a tour of the Planetary Society office, which we don't do much anymore, not since the pandemic, but if you do, directly opposite that photo of him throwing that switch to figuratively start a SETI search, but is another great example of our involvement with both the search for life, but also life's ability to, well, as Jeff Goldblum put it, life finds a way, is the life experiment, right? Let's say at least a couple of words about that, and the little target.
Life experiment.
Yeah, right. That's 2 words.
Okay. Living interplanetary flight experiment, where we developed a biomodule, basically like kind of half a hockey puck, but made of titanium with all sorts of internal features to survive the anticipated 4,000 G impact when it came back to Earth on the Russian Phobos sample return mission, which ended up going to space, orbiting the Earth a few times, and then exploring the ocean of Earth. So the concept was to test the ability of life to survive life had been tested in space, and life had been tested outside the magnetosphere a couple times on the moon. But to actually do that for a few years was the goal. And so everything from spores, bacterial spores, to archaea, to the seeds, and at the other end, and your favorite tardigrades, otherwise known as water bears, that tend to be very rugged and can survive the vacuum of space, at least when other people fly them.
So I'm guessing that this book, you had it all locked up before the announcement of what happened on Mars, Perseverance's finding in Jezero Crater, Chayava Ball. So those leopard spots. Am I right about that? I mean,
that is correct.
It just kind of says that we're still learning stuff pretty quickly, doesn't it?
Oh, yeah. And this is, it's a strange field, not in a bad way necessarily. SETI's the ultimate example of a strange field, because you can spend decades doing really legitimate science and not ever find what you aren't even sure is there. But it's one of those things that if we don't look, how do we know? Where broader astrobiology, they do everything from considering the origins of life and what's required and how it happens on Earth, to figuring out what might non-Earth other permutations of life look like, and most importantly, how do we look for it in, for example, we go to the surface of Mars and we drive a rover around, let's say we call it Perseverance, and we look for things that might be evidence of past life, and then in a theoretical, hopeful world, we return the samples to Earth to use the big laboratory on. And so, yes, indeed, the book was finished before they found that particular sample and the interesting leopard spots, which, by the way, not caused by leopards, just a similarity. Threw me for a while. There's a lot of great work going on in astrobiology, and the Planetary Society even hosted a small workshop with some of the leaders in the field, trying to look at what's next and where we could fulfill roles in helping to advance the search for life, which is one of our, along with planetary defense and planetary exploration, one of our core enterprises of what we do.
And that Search for Life workshop, it was my honor to be involved with that. It was an amazing collection of folks. And I'm sure that kind of work will continue. Doesn't it just kill you? It's killing my dog downstairs, apparently. Doesn't it just kill you? No. He's very concerned. He's concerned that we've left all those wonderful sample tubes on Mars and inside Perseverance, and we can't get the damn things back home. It just kills me. I don't know if it kills you.
Apparently, you swore, sort of.
Kind of. That's about as far as I'll go.
I know, but you don't go that far very often. So.
Wait till you hear me if the dog keeps barking.
He's an example of life on Earth.
Well, are you any more optimistic about the search for life than you were 10 or 20 years ago? That we might find something?
Way that there are?
Yeah, that something's out there waiting to be discovered.
I'm more optimistic now than 10 or 20 years ago. Certainly if you went like 25 or 30.
Okay, 25 or 30. Do you recall?
Yeah, I am, but generally no, because my assumption has been there's so much stuff out there that it's just hard to imagine life not evolving elsewhere. It gets much harder when you start saying, how about on Mars? Well, we have one laboratory right now that has where we study life, and it's called Earth, and we kind of know what happened there. We know really pretty darn well, but it gets a little fuzzy when you go back 4 billion years, although they do an amazing job. And so studying one laboratory, we see life pops up fairly early on a geologic planet's timescale in Earth's history, and it's pretty rugged, and it finds a way. But we don't have any other laboratory. We have no other place, so we've done the experiment thoroughly enough to know whether that's generally true or not true. So was there life on Mars? No idea. Neither does anyone else. And life on Europa in the subsurface ocean, that's a really exotic one. No idea. Life on a star within 10 light years? Probably not, maybe Proxima Centauri, life around the M-class red dwarf stars that are friendly and cool, but really hostile with spitting out nasty ultraviolet and particles. We don't know. That's part of what makes it interesting. But it's one of those things where people are learning a lot all the time. But since we don't know what we're looking for at some level, but we certainly don't know how prevalent it is. So even though within space in general, I'd say you must have had life lots of times, especially now that we found, there's on average 1 planet or more per star in our galaxy. There are 200 to 400 billion stars, so therefore that many planets in our galaxy. Not just our galaxy. Then you get to the ridiculous, there are another 200 to 400 billion galaxies. So the statistics, if life is anything other than just a miracle, then it's out there. But whether it's out there close enough and whether we know how to look for it, I don't know. That's why it's cool. That and the fact that it's rather profound.
We are going to get to some more of your questions and comments here. As I turn with Bruce to away from his books, which I do highly recommend, it is a terrific introduction to the search for life, I think, and one that the kids, particularly in that age group, but that are going to get a lot out of. I did as well. A lot of the stuff he's just talked about, like that world circling Proxima Centauri, it's in the book. I don't know how he got this much stuff into it.
Yeah, so quick, people, if you get the books, consider doing a review on Amazon.
Oh yeah, sure.
Especially this series, it wasn't as actively encouraged and pushed, and that's what helps get them out there more. Learner's doing a great job of getting it out in libraries all over, and that's wonderful. And as they point out, that means you get, for every book, you get 10, 20 people, kids interacting with that one book, so or whatever the multiplicative factor is that I've forgotten. But reviews would be helpful, especially because if one person comes in and they think I look like a bad person, and so they say it's terrible, you need a couple people to say, well, he looks like a bad person, but it's a good book, if that's what you think.
He's a good person. We're almost into bonus time here, as we frequently are on book club series. And so we're going to do that. I know Bruce is able to stick around for a few minutes because I got more that I want to talk to him about. But first, Takwa says, how long before we are no longer able to enjoy a full solar eclipse?
That is, so right now we have this amazingly wonderful
coincidence
that the moon and the sun subtend roughly the same angle in the sky, and so you get total solar eclipses, and also annular because of the elliptical nature of the orbits. But as it moves away, eventually you will not get that, and I don't remember the exact estimate, but none of us have to worry about it or our next few gazillion generations, because it's millions of years off. And I'm sorry, I stopped being really attentive when it passed 100 years, but it's millions, and I don't remember whether that's 1 or 10 or 100, but it's off a ways, longer than you might expect.
Got a great question from Diana. I'll get to Dave in a moment. Wouldn't putting SETI searches on the far side of the moon make for less or fewer interference problems? Well, there's been a lot of talk, right, about putting radio telescopes on the far side?
Yes.
Okay, next question.
But let me quickly mention, obviously, you have some serious challenges to deal with. You're never, well, I won't say never, you're not in the near future, even if you can manage that and manage the setup, the pointing, the communications, which, by the way, it can't see Earth, so you have to communicate with an orbiter to get back to Earth. Even when you get those things done, you're not going to end up with a big, giant 100-meter telescope like the UCLA group is using, the West Virginia Green Bank telescope. So you're not going to get as much coming in. But yes, the really good news is that you take care of the interference, the radio interference. So it's a very good idea, but the implementation is hard and expensive and has other issues. But someday. It's a good point.
Here's that question from Dave, and it's a good one. Do you have any advice for someone thinking about writing a children's science picture book, other than don't do it?
No, that's just when I'm pushing the deadline and it's 1 a.m. and then it's like, oh, don't do this, don't do it.
Never again.
No, but on the flip side, when I'm not sleep deprived and when I look at the books and I hear cute stories of kids who want the books read at night, and it's very, very rewarding. I lose track of that when I'm on a deadline, but then I remember again. Advice, I'm a big fan of real images. And so if you can use real images, because in the space business, it's been a lot of effort and amazing technology that gets us what these things actually look like, whereas you often end up with cartoony versions of that. And that's just, that's my pet peeve. And sometimes, like if you're wondering what exoplanets look like, you have to use art, because you put the pictures in, but it's like a dot. And it's not very exciting when you see a planet as a dot, or don't see the planet at all, which is what's true of most exoplanet hunting that we do. So that's kind of one specific thing. Writing and then rewriting to try to get to the right age range and keep it limited and focus on what are the kids going to get the most out of? What's the fundamental concept? What you only have this many words. What do you need to convey, and what can they get later on? And even though you want to tell them that now, it's not part of the core. That's my thought. But thank you for asking. No one's ever asked before, so I didn't have a good answer.
Dave, thanks for asking, and good luck. Go for it. Timothy is keeping us busy. Here's a statement. This abundance, diversity, and sheer density of life forms sets Earth apart within our known solar system. The presence of such a vast array of complex ecosystems and species would represent a unique finding in the search for extraterrestrial life. Damn shame if we humans mess things up with these wars and pollution. We must find the balance. I'm with you, Timothy. There was another one here I want to catch. Where did that go? William said, there are those who believe that life here began out there. Tell us about panspermia.
Okay, that's the second time you've sworn. Sweared? No, I'm not really. That's just the expression for life, what you just described, life gone originating elsewhere. Well, that was actually part of what was being explored in a way with the Phobos life capsule, if it had worked, which was the concept of, it would have only addressed one piece, but one tiny piece of how can you have something kicked off Mars? Well, yes, you can. Can you have something survive as makes in space? Valid question, but would have done nothing to answer that. Can you have it survive on the shortest trips that are orbitally possible? And that we were a test for. Basically the biomodule was a simulated asteroid, and so they weren't sitting on the outside, just they were simulating organisms, spores, microorganisms that are hanging out inside a rock, and then suddenly they feel a big shock, and then they're cruising through space, chilling hard, figuratively and literally, and then will they survive? And obviously you have the re-entry and stuff. So there are thoughts that, for example, Mars we think was much warmer and much wetter and a better place for life back 4 billion years ago-ish. And so what if life evolved then? And then you had a big impact that threw rocks off that actually kept organisms hibernating, whatever, inside the rock, re-entered, were big enough that they didn't melt and die. And so in that respect, you start life on Earth. You started on Mars, but then it came to Earth. And so, to quote in a totally different context, then you end up with we are the Martians, not the Earthlings. So do we know if that happened, could have happened? We think it's plausible, but challenging. And it's one of those, I don't know, but it's an intriguing possibility that a lot of people have pondered and think about. Well, maybe not a lot of people, but a few people like you. Good job.
So enough of this speculation and wonder about the possibility of life across.
Somebody say wonder?
Let's talk about us. Let me show everybody something that is one of my happiest and most prized possessions. It's right here. It's hanging inside this room where I'm speaking. And yes, it made Bruce smile warmly, as I hoped it would. You see this collage? This was presented to me by the chief scientist who assembled it and took most of these photos, I think. When I backed off from hosting Planetary Radio, turned it over to our colleague Sarah. And there's so much fun stuff here. I just love this. I got stuff all over my walls. Most of it I totally ignore. This one makes me happy every time I look at it.
That makes me happy. I haven't looked at it in a while, or looked at those pictures in a while. Did a lot of goofy, fun stuff over the 20 years. Yeah. You Planetary Radio guy, you.
Yeah, and that's why you think I'm wearing the sweater just because it's a cute sweater. I'm wearing it because I could lift it up and show off the first generation Planetary Radio t-shirt. Give us 30 minutes, we'll give you the universe.
I'm going to claim that I came up with that.
Did you? Maybe you did. I have no idea. It wasn't me. I know.
I mean, obviously, I stole it from a radio station saying,
right.
Give us 30 minutes, we'll give you the world. But I figure we go beyond that.
Well, one of the greatest pleasures for me of, being a part of the Planetary Society, other than supporting our wonderful mission in all of its facets, has been all the fun stuff that we've been able to do together. I mean, for 20 years, I can't say it anymore. You are the only person who has been heard on every single episode of Planetary Radio.
It's a lot of pressure.
Because of your segment of the show. What's up?
Yeah. And I think people actually listen to it.
I think so.
I enjoy doing it. I enjoyed doing it with you. I enjoy doing it with Sarah. And we do a different modified version, but still hopefully fun stuff. And then there were all those crazy things we did back in our youth when we were getting run over by rovers and crazy.
Fun stuff. So you're a scientist.
Well, supposedly.
You did a bunch of stuff for NASA and other agencies. What was that group that you were part of for years? San Juan Institute, PSI, Planetary Sciences.
Yeah.
Research scientist. Spent some time in D.C., learning about that stuff. Went to Moscow, right? Did stuff with the Russians or the Soviets?
3 times. I participated in 6 failed Soviet or Russian missions.
So what is it about your job here and the mission of this organization that has kept you around all these years? It kept you being creative and fun?
Partly the ability to at least occasionally be creative and fun, which when you're buried deep in a scientific paper trying to figure out every single detail that someone will call you on, you have more of those moments where you wonder, like the one I talked about for writing these books, where you kind of go, oh my gosh, I'm so deep in the details. What Mars isn't important. What's important is this little channel here that's got something going on in the thermal infrared. Anyway, that's not important. What is important is I get so much out of working for an organization where I get to do different things, like this, science-related things, technology management. But we're working with a lot of people who are very excited about space and the ability to reach out with things like this, with you, Matt, with Planetary Radio, with the books we produce, with just every project we do in sci-tech, as well as other aspects of the organization. We're communicating it out to the world, particularly with the help of our members and to our members. So it's fun for me. Whereas, and I enjoyed science, and I still do some science once in a while. Certainly review a lot of science, but it's different, and there's a fun aspect that I've been able to cultivate that was more than I probably could have otherwise. And what's really made it, Matt?
What?
The people, mostly you. Yeah. the people.
I do agree with you broadly there that it is a great group of people. It is such a wonderful staff. You and I have worked with a whole lot of people who've come and gone at the Society, and they've all contributed in their way, many of them brilliantly. We have, I think, right now the best group we've ever had, and they are great fun to work with.
They are. And don't tell them I said that.
We're going to make that a little clip. We'll post it across all of us.
No, they have to know I disapprove of all of them.
So that's it, folks. I think we're pretty much at the end here. Bruce, I'll probably say it more than once, but thank you for many, many years of being my colleague and friend, and for all the great stuff that you have done for us and our members, and also for these terrific books, which have closed out this long era in your life of turning out these books for Learner and the Planetary
Something I
Society.
never thought I'd end up doing, but I've gotten a lot out of it, and mostly I've gotten a background for my web calls.
Thank you, everybody, for joining us this evening. It has been a great pleasure to have you. And stick with us in the member community and in the book club. As you can tell, lots more still to come. Once again, Bruce Betts, Chief Scientist of the Planetary Society. Thank you so much, my friend.
Thank you, Sir Mat Kaplan.
Are We Alone? And the Size of Space, published by Learner and authored on behalf of the Planetary Society by our Chief Scientist, Bruce Betts. I'll be back with the next PlanRad Book Club edition on March 14 with astronomer and astrobiologist Caleb Scharf, author of The Giant Leap. Planetary Radio is a production of the Planetary Society. Our associate producers are Ray Pauletta and Mark Hilverda. Post-production is by Andy Lucas. The Society's member community is led by Amber Trujillo. The producer and host of Planetary Radio is Sarah Al-Ahmed. I'm Mat Kaplan, at Astra.